Question 11. Raoul is the manager of a restaurant and he wants to find out how many often local people exist in a restaurant. He's going to carry out a survey using a questionnaire. Design a simple question for Raoul to use on his questionnaire. So, good question for you. As long as really you are asking a question, putting a time frame on it, you're alright. So, he wants to find out how often people go to a restaurant, so how many times. Do you go to eat out, or to a restaurant to eat out? How many times do you go to eat out in a restaurant? Each month, week, year, whatever you like, but as long as you put a time scale in, you have to do that. Alright, if you put a question mark there, it means nothing, because each person who reads it could think, does it mean in a week, in a month? It would change the response. Then you need response boxes underneath. Allowing for every single possibility, and then you've got that one done. Part B then, two-way table shows information of ages in Raoul's restaurant. It carries out a survey using only its customers. Use a sample of 50. You calculate the number of males aged, so here that's the value you're looking at, between 17 and 30 in your sample. So the number of males is 10 out of his total, which is 127, and then you times that by 50, which is your sample size. Into the calculator, 10 divided by 127, times him by 50. And personally, I would then write this down to a certain value, so just write 3.93, and put dot dot dot, and then that roughly equals to 4, because you need to round it up, because it wouldn't make any sense to have a point of a person. You can't ask point of a person, can you? And then Raoul's survey is biased. Two valid reasons for why this is. So, why is it biased here? Well, let's read the question previously. A two-way table shows the information about ages of the customers in Raoul's restaurant one evening. So, what's going to be an issue there? Well, look at the sample. What's your problem with ages here? Or gender even? You know, you've got a difference in amount, haven't you? So one of the bias points is that it could be biased to gender, i.e. not equal male and female. And then another one, what else could you do? He only does it on a single evening, doesn't he? So only done on one evening. Question 12. The table gives information about the distance in miles from travel to work. Draw a histogram. Right, so histogram. You've got your class width to create, and then you've got your frequency densities to do. So what are class widths? Well, the way to remember a histogram is it's the gaps, the importance, the areas of these values in themselves. So it's the gap here. Between here and here is 5. Between 5 and 10 is 5 again. Between 10 and 20 is 10. Between 20 and 30 is 10. And between 30 and 50 is 20. Well, then you're dividing all these values to get the frequency density. So 15 divided by 5, 3. That divided by that is 3.4, 1, 0.6 and 0.1. So we've got our frequency densities up the side. So 3.4 is our biggest, so if I just go up in whole values, and then we're plotting our histogram. So the first one is between 0 and 5, so I'll go up at 5, and I'm going up all the way up to 3. Then we go across there to get our first bar. The second one's between 5 and 10, that's 3.4, so it's slightly higher. So 4 squares higher on top. Next one's between 10 and 20, and that's 1. That's a nice one to draw, just nice and full up to 1. We go across. Then got 20 and 30, that's 0.6, so 6 squares up. And then you've got 30 to 50, which is 0.1. And there's your histogram completed. You then asked, the histogram below shows information about the distances in miles that some women travel to work. X women travel between 10 and 20 miles. So I put X just in there initially. Find an expression in terms of X for the total number of women represented by histogram. Well, what we've got here is if I count the squares, it's a 10 by 10 grid. So that's 10 squares up, 10 squares across. So in effect, what we're doing here is we've got 10 times 10, which is 100. So 100 little squares is equal to X. So if I then work out here how many other squares we've got, well, that's 5 by 10, 20, 30, 40. So 5 times 40 is 200. So 200 squares in there. So if X is 100, then that's going to be 2X, isn't it? This is then 5. Now this one's not as easy, it's by 28. Now 5 times your 28 then is 140. Now that's not easy to talk about in terms of X, so I might leave that for a second and see if anything else helps us. This is 4 then times by 10 again, which is 40. And then we've got here 1 by 20, which is 20. So if I add up the total number of squares overall, I think that's probably the best way of solving this question. 200 plus 140 plus 100 there, don't forget that one because that's the total, it's included. This then is 40, and this then is 20. That's 60, 200, 400, 500. So 500, if we've worked out that 100 is X, then at what's 500? Well, that's 5X. Very, very tough question that. In terms of the phrasing of it, it's very careful, very clever. And then we've got our final question here, which is question 13. So Isabel plays a game against Eric. What's going on here then? Isabel is twice as likely as Eric to win the game. The probability that the game is drawn is 0.1. Work out the probability that Eric wins the game. So if Isabel and Eric, Isabel is twice as likely than Eric to win the game. Twice as likely to win Eric. Well, first of all, if we take 0.1 off, that gives us 0.9 of the probability left to share. So if that's 0.9, and we've got 3 parts here, if I divide 0.9 by 3, that gives me 0.3. So Eric then is 0.3, and Isabel will be 0.6. Well, the probability Eric wins the game, so probability of Eric is then 0.3. Again, you can work that out in different ways, but that's one method. B. Calculate the probability all 3 games drawn. So it's probability of D, D, and D. What's the probability of a drawn game? 0.1 times 0.1 times 0.1, because it's probability of drawn, and drawn, and drawn. Now, and is times. So then that gives you 0.001. Now C, I'm guessing, is going to be a stinker, because it's the last question. Work out the probability that Eric wins at least one of the 3 games. So, how do we work that out then? Eric wins 1 win for Eric. Well, the easy way of doing this is to think about what's the probability of that not happening. So what needs to happen so that he wins at least one of the games? Well, you could have probability of Eric winning first one, and then anything else on the other 2. You've got the probability of anything happens on the first one, then Eric wins the second, and then either Isabel or draw wins on that one. And then you've got the probability of anything but Eric, and then Eric winning the last one. So I'll go through how we work this out. Eric winning is 0.3. Then on the second goal we want anything but Eric. Now anything but Eric is 0.7, because it's the draw and Isabel's chance. and the same thing again. Then we've got anything but Eric, Eric, anything but, and then we've got anything but, and then Eric. So you only need to work out one of these because they're all the same. So I think it's, just double check, I think it's typed that in properly. 0.147, 0.147, and 0.147. So if we add them together, that gives us 0.441. So 0.441 then, that's a probability of Eric and anything and anything, anything Eric, anything Eric and Eric. So what do we then do? What else have we got left? What have we missed? It's a question, it's a very clever phrasing, isn't it? Because it's not just one win, it's at least one. So with at least one, then we've also got the probability that Eric can win 2, and then anything else. So that's 0.3 times 0.3 times 0.7. And we also have at least in winning 1, so he could win all 3. Now I'm also going to take this number and times it by 3 because you can have it in any order, A, E, E or A, A. So we times that value by 3, which is 0.189. And then we've got the probability also of Eric, Eric, and Eric winning all 3. That's 0.3 times 0.3 times 0.3. So 0.027. So then the overall probability will be, if I highlight in red, this value, and this value here, all added together, which then gives you an answer of 0.657.